tropical cyclones with higher wind speeds, a wetter Asian monsoon, and more intense mid-latitude storms. Observing and forecasting tropical cyclones remain in utmost importance. A very distinguished research professor reminds us of the progress made within the past 50 years and how such knowledge can help reduce damage and loss of life.
What everyone really focuses on is the position of the tropical cyclone because of the strong winds in the inner core of the tropical cyclone. Those strong winds drive the waves, and so what the Navy needs to know is what is the highest winds in the storm, but also what is the structure of the storm. But we can have monster typhoons out in the western North Pacific. We can also have smaller than average tropical cyclones, and they can form in a very rapid time frame, and not only can they spin up very fast, but they can all spin down very fast. So out in the western North Pacific, the fleet and the bases around the Pacific are threatened by these typhoons actually almost all year. From the beginning of the season could be as early as February and continue through December into January. So it is a great threat to our fleet, both offshore and onshore. So we need to keep the ships outside of the 35-knot wind radius and outside the 12-foot seas. If you have to bring the ships out of a base, when do you have to get them? Where can they move in order to remain safe? In the old days, if they could forecast it for 36 hours, that was wonderful. Then we went to 72-hour forecasts, and as we learn more, and again, the Office of Naval Research and its various field experiments that they've supported over the years in the Western Pacific, we've made advances in tropical cyclone track forecasting. And again, it's the people at the Naval Research Lab who do the numerical modeling for Fleet Numerical, and Fleet Numerical runs those numerical models and produces the forecast for the fleet throughout the western North Pacific and other parts of the globe. One of the great advances in tropical cyclone, as you can see, this is the satellite image. This is done because of geostationary satellites, which are 22,300 miles away from it, positioned over the equator. They look down and are able to see this whole expanse of ocean. It's whenever we could see every single storm around the world all the time that we made this great advance in being able to observe the intensity from satellites. When we were able to do that, we were then able to supplement that from the few Raywin sounds, which are the balloon soundings which go up and measure the wind, temperature, and humidity. That's all we had in those days. But when the satellite came, with especially the geostationary satellites, with these atmospheric motion vectors, which tell us the winds over the ocean that we didn't know, our models got so much better. But then we've also, and this is especially true at Fleet Numerical with the help of the Naval Research Lab in Monterey, they developed these advanced models which make use of this new observations over the ocean that allow us to make these better forecasts. So better observing technology from the satellites and much faster computers, much better models have made it possible to make these kinds of forecasts much more accurate, much longer in time. We now make 5-day forecasts. And what I am working on now with medium range weather forecasts is to extend that beyond 5 days. We are now looking at 15-day forecasts twice a day and out to 32 days twice a week, just because of our cooperation with the different field experiments from the Office of Naval Research. So we're supporting now a NASA field experiment called HS3 in the Atlantic, in which we've been looking at storms like that developing in the Atlantic so that they can plan their missions with these global hawks, which fly, they're unmanned aircraft that fly at 60,000 feet and are able to drop sun that's right down through the entire storm. Rather than just seeing the bottom of the storm, they are able to see the whole storm. And this those instruments on board the Global Hawks are potential satellite missions or instruments in the future. So we're looking to help even down in the next generation of satellite products as well. So it's been a very exciting experiment this summer. We've participated for 3 years now with this field experiment, which is a cooperation of NASA and NOAA and other agencies, especially the Office of Naval Research, is where we get our funding to participate in these kinds of field experiments. It's what keeps things really interesting for us, interesting for our students, interesting especially for our PhD students and postdocs. We work closely with the operational part of the World Meteorological Organization, the Tropical Cyclone Program. It had to be that all the nations in the world had to cooperate. They had to share their data sets. And that's really another reason. It's not just that the United States could do all this. The United States couldn't do all this. We had to have the satellites which are launched by Japan in cooperation sometimes with the United States. China has now their own satellite program. They have to share this. We have to all work together on this kind of a problem because it affects people all over the globe. We get the observations into the models are better, the outputs are better, we make better forecasts, we provide the forecasters better products, the forecasters are better trained, they make better forecasts. We use social media, we use everything we can to get the message out and educate people on how they should react. When should you move? Where should you go? Again, tropical cyclones, important to the Navy, and the Office of Naval Research has been an important part of my being able to continue this research for over 30 years now.